So, yep, it's working. Good morning, everybody. Are you awake? That was not the answer that was expected. So, today we're going to talk about, Docker. You usually used to use virtualization to run your projects. You have Vagrant or VirtualBox, or you even run it locally. What actually happens here, you have your host operating system like OS X, Linux, or Windows. Then you install a hypervisor like VirtualBox, VMware, or Parallels. And then inside you run a full operation guest system with Debian or something else. And you have all the software installed you need to run your TYPO3. So that's a lot of mess. Because the full guest OS brings a lot of software that you don't need to run your TYPO3. It simulates the actual hardware, which is pretty intense. Because the CPU that is simulated does scheduling, but you already have a CPU on your hardware machine that is being scheduled, so you lose a bit of power there. And you have a mechanism in virtualization called protection rings that encapsulates your operating system for getting influenced by application calls that might influence the kernel or break some stuff. And that's done twice on your machine. That's expensive too. And of course, you do virtual memory mapping because you dedicate your, let's say, 4 gigabytes of RAM to a VirtualBox machine, and then that memory is mapped onto your original machine, and it keeps track that nothing writes into these memory addresses, and that's all expensive. And of course, you have a own disk in your hardware, and it takes a lot of time to boot the entire operating system, and it takes a lot of time to install it, even if you have automated it using Chef, Puppet, or Vagrant, or Ansible. So it works. I don't say virtualization is bad, but it's a bit ancient right now. What we are going to do, we're going to use our host OS, and we're just going to install a container engine called Docker. And Docker makes it possible to run single processes directly in your operating system, having all the packaged library that an operating system like Debian would bring packaged into that application. So it's basically running a full operating system with nginx, Apache, PHP, FPM, but without having all that hardware abstraction layer in between, so you don't lose any performance. And you can just spin up like 500 TYPO3 project containers on your machine without having to worry about resources. So, how Docker actually works. We have that Linux kernel. Or let's say the container engine kernel. That's basically the same, but that's not a full operating system. It doesn't contain hardware drivers. It only contains the layer of the Linux kernel that is necessary to run applications. And that layer differs by distribution. So basically, what we have a layered structure of software that is packed into a container. We start with a basic image. It's called Debian or Ubuntu or CentOS or whatever you would like. Then we add layers on top of that image. Let's say we install Apache. We have another layer, we install PHP. We have another layer, let's say we package all our project file in there, and then we get an image. An image is basically a packed and snapshotted projection of your running software. It's not like a virtual machine snapshot, which just says, okay, I take the entire memory and all the disk and all the configuration and I snapshot it. It's just the description and the application files that run. And if you have such a layered image packaged and you run that image, you get a container. So a container is always just a running instance of an image. And that container is writable, it can have files in there, and that's the cool thing about it. A container has a full file system, like you would expect it from a regular Linux server. But you can mount parts of that container file system outside. So on my host machine, I have like opdata file admin or opdata uploads, and that's mounted into my container. Or during development, I just mount the entire TYPO3 folder. So I can work locally with PHP Storm and all the files, but the container also accesses that TYPO3 files to run my web server, and it runs on the same machine, and it's very, very fast. And you can have another container, let's say it's a database container, and MySQL is not that complex to run, you just need a basic distribution image like CentOS, and say, okay, add MySQL, and then you connect those containers with a port, because every container has its own network. It's closed in itself. By default, you can't access anything inside a running container. You need to specify what from that container should be exposed to the outside world. And here, because I have my web server running, I want to expose port 80 so I can access it, I can see the web page. But I don't care about SSH, FTP, or something else. So it's a bit safe. And as my TYPO3 just needs MySQL to run, the container can access the port from the MySQL container, but the port is not exposed to public. So that's an additional layer of security. And it gives you a lot of cool functionality I will show you in a bit. And it makes running big projects with a lot of stack pretty easy. So a Docker container is a running instance of an image. It has its own disk. So you get an instance of that image file system and its copy. It has its own network. It can expose ports. A container is intended to run only a single process. Well, we will do something else. We will run nginx and PHP processes in a container because, being honest, it just belongs together. If you talk to a Docker guy, he will say, oh, PHP FPM is a different process. You need to run separate containers and mount that socket and stuff. Why? You can just run web server and PHP FPM and use a mapping process like a supervisor that just spins up both processes. That's always possible inside of a container. That makes your life pretty easy. And you can package up your web server, your PHP, and your TYPO3 together in one container and ship that to the customer. And it doesn't matter if his MySQL is running inside of a container or he has a hosted MySQL solution or even a Google hosted solution. No matter what, the container is a runnable application as long as it has a database server from anywhere. And the cool thing about Docker, it just directly uses the resources of your hardware machine. So running Docker containers on your machine or in production has almost no overhead. They did tests about it, it's like 0.05% or something like that. Not like virtualization where you end up like 4 or 5%. But you need to be aware of some structural dependencies. A container is not persistent. Only images are persistent. So if you don't mount your, let's say, file admin outside of the container, and you kill the container and you spin it up again, it will be gone. So you need to make sure that the files that need to be with your project are either stored somewhere else or they are mounted to the host or some other kind of volume management. And I will show all that to you. A Docker image is, as already explained, a layered concept of snapshots. And that's pretty cool about it because it contains a projection of the complete file system and the file system is layered. What does that mean? I spin up a container that depends on Debian. I add Apache, I add PHP. If I now use another container that's based on the same image, you will only have those basic parts once on your hard disk. Because what it does, it just does a file system pointer to that compressed image, and the running container says, okay, that's the basic file structure, that is now made writable, and only the diffs that you make to that image are stored with the container. So that's basically, if you run 100 TYPO3 instances, all you have as storage on your disk are the 100 copies of TYPO3. You can also surround this by building another image which says copy TYPO3, then you have all your TYPO3 kernel in it, and then you would just mount your extension. So you would only have the difference of the extension on your hard disk and have the image only once. I can tell you after starting with Docker, I freed about 260 gig memory on my computer because I had that many Vagrant machines for that many customers running, and I was almost running out of space. Now I have like 300 gigs left on my hard drive, and it's pretty awesome. And Docker images are versionized, so you can say, give me version from Ubuntu, give me a version 14.04, give me 16.04, or give me Apache 2.4.26, 2.4.27, whatever you like. The versioning is not defined by Docker, so you can introduce any kind of versioning you want. The platforms that use Docker support semantic versioning, so if you stick to that, you will get rollback and all that mechanisms, but you can just call your containers tag foobar. They don't care. And container images can be easily exchangeable. You can just pick your single file Basically, it's just a single file, a layered compression of Git binary diffs, and you can just throw that at a cloud and it works. You can throw that to a customer, to somebody else, and that you can easily exchange that. There's a mechanism called repositories, so you can just push your Docker image like you would do it with a Git repository somewhere, and they don't get code, but they get a runnable instance. That's pretty cool, and it works on every machine. Yes, Vagrant could do that also, but if you try to import a Vagrant backup from a different hypervisor, it will just not work, or you have some kind of migration mechanism and you will lose some settings. Yeah, Docker just standardizes everything of that. When we talk about software running in Docker, there's a term, beware, that's trademarked, that belongs to Docker Inc. It's Dockerized software. Yeah, actually they trademarked that, however they did that. Dockerized software, let's say we have Apache or nginx or MySQL. You have your own requirements, right? You want to change configuration. You want to say, oh, I don't want a default root password, that's password. I want a safe one. But how do you do that if you have a fixed snapshot of that image? Actually, if you run a container, you can give that container a set of environment variables. And the software that is Dockerized is usually built in that way that it can use environment variables to configure itself. So you deploy variables via runtime. What we do when we Dockerize TYPO3, we just add an additional configuration file that says, if global and environment variable MySQL user is given, then please override that with the global variable. So your running TYPO3 image is just configurable via runtime in Docker. That's the usual use case. It's also possible to just start your Docker container image and override the configuration files that are in there by using a file mount to a different configuration file. Because the mounts are executed before the container fires up, the container will read the new configuration file and just spin up. So I will show that to you. We have both cases in our boilerplate, so that will work. So a different mechanism that we will use is Docker Compose, because we don't need a single container, right? We need MySQL, we might need Solr, Elasticsearch, FTP, whatever you can think of. We have a customer that needs 16 containers to run because they have third-party dependencies on WebSphere projects and whatever, and that all spins up in a large environment. And to describe the environment, there have been stacks for doing that. On cloud providers like EC2, they had some XML-ish language to build that. In Docker, that has been standardized. We use YAML and a mechanism called Docker Compose to describe the services that belong together. Let's say we have our container that's named app. It could be also named TYPO3, no matter what. That's our central container that will spin up Apache, nginx, and so on. We have another container called MySQL, because we need a database, obviously. And those two containers will be fired up, and they will run independently. But I need the container MySQL to be connected, to be available in the app container. Otherwise, I cannot access the database. So what I actually do is I create a link to that container. And that mechanism is pretty cool inside of Docker, because the name you specify here, the service name, will also be the DNS name that is available inside of your Docker container. So when you enter your database credentials in TYPO3, you will just say connect to host that's named MySQL. Be aware if you build mail solutions with that. Some software like Shopware uses Zend hostname validation, and a single hostname is not valid during to RFC convention, whatever. So that will not work. But in our world, it will all work. But you could also use dot annotated names here that must not be named MySQL, that could be named mysql.mycompany.com or whatever. So there's no limitation to special characters in here, but you need to be aware that you need to write the name in the connection credentials of your other container. Then we need to tell the operating system that runs the container which ports are accessible by the outside world. And what we do here is we specify that the port 80 should be available from the running TYPO3 container on port 80 on our machine, if it's not already in use. because ports can only be run once, like with every other software. If you have an Apache running on your local OS X machine, and by default you do, that will not work. So you would specify a different host port, let's say 8080 or 8000 or whatever. The internal port stays always the same because it's running nginx with a default configuration, so it's listening on port 80, but you map that to a different port on a host machine. You can also do this with a SSL port and stuff. For SSH, if you want to expose that to the outside world, you need to remap it because you have a host machine that runs SSH somehow, and port 22 is always in use. Otherwise, you would not be able to connect to that machine. And that port mapping mechanism also exists for mounted volumes. So if I want to have file admin persistent on my hard disk and being editable by some other software or customer, then I just mount my opt file admin or whatever path you like inside the container. And as the container has its own file system, and we build the containers in that way that TYPO3 resides in /app/web, then I mount it in there because TYPO3 will look for that path. And I can do that with as many volumes as you like. You can see I omitted a full path here. That's a named volume. That concept has been introduced with Docker 1.10. Docker will automatically manage where that volume resides on your disk. You might even not be able to find it. You need to read through a lot of JSON, but be assured, even if you restart your container, that volume is there. If you want to do backups of that, you need to hack a bit into the Docker API to find the real file path and copy or backup file admin. Volume inspect. Yeah, but that's a bit long JSON. You need to parse it. Yeah, but you need to parse it to build a backup script. Yeah. Usually I don't care about that either, because if I run that in production, I have these engine volumes attached to a volume driver, and that's another mechanism inside of Docker. You can say, oh, I have my NFS cluster or my GlusterFS cluster that runs with a single click, and say, okay, that named volume resides on my scalable data system cluster. And so I have my file system spanned across 5 machines and replicated, and I don't care about it. It's just high available. I don't make backups. You could specify all environment variables by hand inside of a compose YAML. What we usually do, we expose them inside a YAML file because that's just easily writable and versionable. And you can override some environment variables. Let's say, like you see it here, we have the basic environment variables, and then we have special variables for production usage. But there's still a lot of more to that. What's special here? We use a already built image to run that environment on a cloud that's necessary, because a cloud is usually not able to build that on the fly. On your local development environment, as I will show you right away, this will just say build dot, because we have the local file system, the project on our file system, and we want the project to be rebuilt. So that's it for explanation. Let's do hands-on. If you don't have Docker already installed, whatever operating system you use, click on docker.com, get started with Docker. And if the internet is stable, yes it is, they will detect which operation system you use, and they will scroll to the download that is prepared for your operating system. In my case, it's Docker for Mac. If you're using Windows, it's here. If you're using Docker for Linux, it's here. Docker for AVS, Docker for Azure, whatever. So in my case, it's just Docker for Mac. And then I will start to download. Download. Please. Do not die, Chrome. Yeah. Ah. Now I have a download. As you can see, Docker Engine is about 110 megabytes. I don't know how big it is on Windows. Wait to download to be finished. Of course, I can't show the Windows setup here because I don't have Windows. On Mac, it's now just drag and drop. Not in the browser, in the application folder. I had already installed it, but I don't care. Replace. So now I need to make sure that my other Docker environment isn't running. There are different ways to run Docker on your Mac. For developing with TYPO3, it's most easy just to use the native OS X version. If you're trying to use more complex software like Shopware or Magento or Neos, it will not work because the file system access of Docker for OS X is pretty slow. So usually we'll end up with response times in more than a minute. But for TYPO3, you will have less than 200 milliseconds. So it's pretty good. Now I start Docker. Yes, I want to run that application. Yes, it needs privileged access. I'm aware of that. And now I have that nice Docker whale up here. And it says Docker is starting. What actually happens here, because OS X is not a native Linux kernel, they fire up a virtualized Linux kernel. And it's not a full VMware. It's running on QEMU. That's pretty close to the native OS X kernel, so it can use much more resources and be faster for CPU and memory scheduling, but somehow they can't manage to get the full disk speed. And that's why you have settings here that say you can run that many CPUs or that many memory, so you can protect your operating system for using all the resources for Docker. On Linux, per default, it uses all the resources because it's not virtualized. But you don't know anything about that running VM in the background. It doesn't matter. So let's see if I have Seller. No, that's the wrong one. I just need to deactivate my other Docker environment. Why don't I just restart it? Which Docker? Yeah. Good morning. Everything is up and running fine. Show me the output. Probably I fucked up my environment because I have like 4 Docker installations on my MacBook. That can happen. The entire Mac? Yeah. Nah. Well, as we had that issue this morning, I just try with the beta. That's the wrong one. Are you sure about that? Come on. You should not have trouble with that. That's just because of my MacBook. Nope. Let's see, where do we have the beta version? Beta channel. Yeah. No, that's not necessary. Oh, but I could have one. Yeah, that's right. Yes, thank you. That I almost forgot that. So, if everything worked fine, you should see, if you run docker ps, that output. Does everybody have that? No. Were you able to download the installation file, or is the internet broken? Yeah. Is it working on anybody's machine? Yeah? Okay, some people. The others might run the installation while I show some quick introductions. And to give you a quick overview how all this works, there's this central repository. It's called Docker Hub. Usually all the images that you use are located there. It's just like GitHub. It's the most famous one. You can use other Docker registries, but then you need to add them and stuff. By default, everything that runs from Docker is started from Docker Hub. So if I do like docker run -rmti CentOS, it says I'm unable to find the image for CentOS locally. I'm just gonna download that packaged image that I already mentioned from Docker Hub to your local machine. And then it will fire up a container built from that image, and now I have my CentOS shell. And it's a full CentOS already running. So I can do yum install Apache, and all the stuff you would usually do. But I don't want to do that every time I needed a CentOS with Apache running. So what I would do, I would stop that container, and now the container and my Apache download is gone. The file has been destroyed and removed, so it's gone. It's not persistent. I would, just a quick word, one step back. Those parameters here, that says docker run me, yeah? Even more? More? Enough? So, what I actually do, I say docker, run me an instance of the image CentOS. The other flags are --rm, that says, if the container is stopped, remove me all the mess he created and the persistence and so on. Otherwise, you would have the instance of the container present. You could be able to start it, so it's not that ephemeral as I mentioned. But as the container gets a random name, it's hard to find it again. And as Docker is not built for that, you should always use a fresh container, and as you can see, it starts in like a second. I don't care if it's persistent or not. Those flags, -ti, if I omit them, what will happen? It will execute the shell command inside the container, but will not expose that to my actual shell. And as a shell without commands just terminates, it does nothing. So -t says allocate my TTY, so my input device of my shell on my computer, to that container, and I says please wait for input. It's interactive mode. Otherwise, it will just terminate again. No, it won't. Why didn't it terminate? Okay, usually it should terminate. Okay, it doesn't terminate. Maybe that's an update of Docker 1.12. So, that's the basics of running a operation system inside of Docker, and as you can see, it's pretty fast. And if I try it with Ubuntu, download latest Ubuntu, and as you can see here, CentOS was just one layer. Ubuntu is already 5 layers, because the Ubuntu guys splitted up their kernel and their modules in a way that they can reuse parts of that image with different Ubuntu versions. So what is actually necessary to run the latest Ubuntu version, which should be 16.10 latest beta or whatever, it's usually just that image that differs from 16.04. So they share that image layers again, even for the operating system, so you won't get a copy of those files on your system. It saves hard disk drive. And now I have a Ubuntu console. I can run apt-get install Apache. If I run apt-get update in front, otherwise I don't have source links. Yeah, as you can see, you have a full operating system running. So, what we do now, we will start a Docker file. If you want to build your own environment with Docker and say, I want a Ubuntu with Apache or nginx, you always start with a Docker file. A Docker file is basically the command instructions to set up an image. And Docker files always inherit from different other images. The first image is a, what's it called, root, default, whatever. So that's just an empty Docker kernel that doesn't even contain an operating system. So you would usually start from an operating system. So I say, from Ubuntu, run apt-get update, run apt-get install --y. So confirm installation, do not ask if I want to. I'm pretty sure I want to. And yeah, that's basically it for the first time. And now I can say, Docker, build me a new image that's tagged, so the image is named Ubuntu-Apache. And build it from the current location. So Docker will search in the current directory for a Docker file. You can have more than one Docker file, but then you need to specify its name by using the -f parameter dockerfile.to or whatever. It can have any file name that you want. But I will just say, okay, Docker build me a new Docker image that is named Ubuntu-Apache. Otherwise, it will get a random hash name, and that's pretty hard to use. So always name your images and use the local directory. The directory is important because Docker will expose all the files that are in your current directory to the Docker engine to be able to build the image. Usually you have to copy your TYPO3 sources or config files or whatever. So it can only use the files that it sees inside the directory. But be aware, if you are too open to your Docker environment, it will copy everything that is in your current directory. So if I would run that from my root dash, that would be pretty hard. And it will be even hard because I'm trying to run it from my desktop, I guess. Yeah, that would be stupid. So let's move the Docker file to a clean directory. mkdir T3DD16 Docker. Move my Docker file there. T3 Docker. And now I say Docker build tag Ubuntu-Apache dot. Now we can see it executes. It pulls the image from Ubuntu if it wasn't already present, but it was present, so nothing has been downloaded. Then it runs that command, and that command will also create an image. So every line that is being executed in a Docker file creates a new image. But I only want to use the last version of it because I don't care about all those temporary layers in between. And now we can see all the output that is done by Ubuntu, and yeah, the package Apache doesn't exist, so the build failed. Thank you. So let's try it again. And a pretty cool mechanism that is already in use, if I am able to scroll up wide enough. The layer apt-get update did not get executed again. It's cached. Whew, how cool is that? It can detect that that the layer of that command being executed, the base layer did not change, and therefore it assumes that the outcome of that command will be the same. So it just cached that layer for us. That's a problem if you want to build an actual container that is fresh with apt-get upgrade and all the stuff, because that command would also be cached. But for now, if in my development environment, I'm totally fine with that, and it's running pretty fast. And now it's gonna install Apache. That takes a while, and yeah, it's not readable. And now I have my finished built container. And now I can say docker run rmti ubuntu-apache. And now I have my Ubuntu, an instance of my freshly built image that contains Apache 2. And now I destroy that again. And if I do that build again, remember the cache, it's done. So if you need to rebuild an image and you just change some files, it will execute all the installation commands not. It will just copy over the changed files, and your build takes like less than a second. What we usually do if we have containers that are built for productional usage, we add -- no cache, so that it will execute the commands freshly, and you always get a fresh build because you want to have the latest software updates and security fixes installed. But that takes a while. But for your development environment, having the Docker cache in place is totally good. So, and now we could, let's say we create another Docker file. No, cp Docker file. Docker file -php. Now I'm going to edit the Docker file PHP and say from Ubuntu Apache, I don't need to execute that, please install me PHP 5 FPM. Docker build Ubuntu Apache, now we call it PHP. No, that's the tag, that's the file name. And we need the build context dot. Has no install. Oh, today is not my day. Installation package images. Well, as you could see, it would use the already built image layer from our Ubuntu Apache to build up a new image that has PHP in addition, and we could run that image. But you don't need to take care about that, because some awesome guys, namely Markus Blaschke, Florian Tatzel, Josef, I forgot your last name, I'm sorry about that. And some other people I think I didn't meet already. We built a large environment for you. So what we actually did, we founded a GitHub open repository, and we prepared a lot of Docker files and images for you. Let's see what we did. We prepared almost everything that you might need to work with it, and we even have a lot of operating systems versions in place. And all that is automatically built and uploaded to the Docker Hub, so it's publicly available for you. I think we're currently building 180 images, right? Something like that, and the build takes about 3.5 hours, and it's built daily, so it's always up to date. And in addition to that base images that have already installed a pre-configured Apache PHP FPM and all the other stuff, we have prepared a TYPO3 Docker boilerplate. And that is the one that we're going to use now. So if you have Docker running now, I hope you do. Yes? No? Yes? Cool. You just go here, clone that URL, git clone TYPO3 Docker boilerplate. It's pretty fast because it's not that big. And now I'm going to open that in PHP Storm. Nope. Just clone it anywhere. PHP Storm. Open that. Open that. Where is it? T3DD Docker boilerplate. View presentation mode. So, as you can see, that contains pretty much files. But there's a good documentation and a good README. I will quickly guide you through it. What we prepared. We prepared 3 different Docker files for usage in different environments. So usually what we're going to do, we're going to use the development environment. That development Docker file contains some information what you can choose to run your TYPO3 on. And if you want to, for example, let's pick PHP 7 because it's awesome, and I want to pick Ubuntu 16.04, and I prefer to use it on Apache, then I just copy that line, because that's our image for that, that's pre-built. And here where it says inherit from that base image, I just overwrite it, and now I have Apache 16.04. And what we actually do is we provide a small Ansible version to run configuration files, because you would want to modify your PHP or nginx configuration, and that's pretty handy when using Ansible. So that's the first one. We choose which base image we want to use. Then we need to have our environment that is composed, so the orchestration, what containers do we need? As we want to develop, we use docker compose develop, we copy over that file, remove the .develop, and then we have that file in place. And as you will see, by default, it will only be the app container that is active and the MySQL container, because those are the essential containers you need to run TYPO3 on, right? We will map to your host port 8000, so you can access it via any project name .local port 8000. Oh, by the way, Docker for OS X uses DNS masquerading to forward every hostname .local to your Docker containers, so it will be all accessible. We mount our app volume, which is basically here. At the moment, it's empty because there's no TYPO3 yet in it. We will mount some temporary debugging stuff where logs reside, and we will mount the Docker folder, which basically contains the we mount the dot folder, so everything inside, so we can access the settings files from within the container. And we use a shared storage mechanism, which will maybe be kicked out in the next version because it's not longer necessary. And we have some environment variables. And as you can see, we also prepared different versions of MySQL for you. So 5.5, 5.6, whatever. Let's say I want to have Mariah 10. So I'll just comment that out. We want to expose our MariahDB port to our MacBook because we want to have access via SQL Pro, right? We don't want to SSH tunnel into that and just use it on your local computer because don't care if the socket is open. We could also have a Postgres SQL server, a Solr server, Elasticsearch server, Redis, Memcache, Mailcatcher, which is pretty awesome to develop local mails. It will catch all the mails you send to a SMTP host and display it in a web UI so you can debug your emails. You could use VSFTP, I have no idea why it's in there. And you can just add anything you want. We could just do, okay, I want to do integration testing like it has been introduced with Codeception. I can say, I want a Selenium container running that runs from an image, and there is hub docker com Selenium. Where is it? Selenium hub. No, that's the grid hub. Standalone Chrome debug. Node standalone Chrome debug. There it is. So that's the name. That image, and it links to app. And now I would have a running Selenium Chrome version that could be accessed via Codeception with a host named Selenium, and I can test my application with that without having to install Java locally or run Selenium server or whatever. It all runs in the Docker container. And basically that container is based on a Java container, and it's all that stack layered stuff. So, but we just want to run basic TYPO3, right? So we said we want to have MariaDB 10. We built from Dockerfile development. In the Dockerfile development, we said we want to use Apache with Ubuntu 16.04. And what we're now going to do is we will say make create TYPO3, because as you have seen, there are a lot of parameters to run Docker commands. And what we basically did is we prepared a make file, which can be run on almost every environment. And it just simplifies a lot of commands that you're going to use, like create a project, start, rebuild the entire environment, do MySQL backup. Then it will create a tar-bset2 file inside of the backup folder here, and restore. Then if you lost all your containers because you have a fresh machine, you can have the MySQL backup, just copy the tar-bset2 file and say MySQL restore, and all your environment is back up. There's also Solr backup. Elasticsearch backup is currently being built, so that will come in the next version. And yeah, commands like that. If you need to see some stuff that runs inside the container, so you want to go inside that operating system, we don't have SSH, but Docker gives us the ability to pick that shell and run it, like you would do it with a running container, but you can pick any shell that is already running. But that commands are pretty complicated, right? So we just said, okay, the command is now make shell instead of that. And we also have a command that runs the TYPO3 scheduler with some arguments, so it's just make scheduler, execute, xbase, whatever. So it's pretty easy. We're just gonna use make create TYPO3, which basically runs Composer and installs the latest stable distribution inside the app folder, which is what you basically would do if you start a new project. And I hope it's running pretty fast. Yes, because I have cached it. No, I don't want the .git versioning. So it just ran Composer. What I got is, where is my PHP store? Ah, there it is. Now I have my app folder with TYPO3, basic TYPO3, nothing else. But that's enough. And now I'm gonna use make up. That's basically the command to say, please fire that all up for me now. And now it's almost running. As already mentioned, we use Ansible to change some configurations. That takes around 15 to 20 seconds at the moment. We're working on it. Our target is to have it in less than 5 seconds up and running. So what I can now do, I can say typo3.local port 8000 / typo3. Yeah, for effect. What went wrong? Went something wrong? No. Maybe it just takes some time more. Why not? Name not resolved. Not Docker local. Yeah, as already mentioned, I screwed up my Docker environment, so I'm just gonna use the thing that I usually use. You should be able to access that URL. No? Who is able to access that? Nobody? I'm not sure. No, that's VirtualBox. Usually I don't use the Docker for OS X version, but it should be somewhere. Registry mirrors. Where is the information about the host that he's using? Well, that's why they wrote getting started guides. Docker Mac Toolbox networking. .local. I have an idea. Probably it doesn't like my Google DNS. Nope. What was the host name on OS X? Yeah, something's always going wrong. Okay, I will just show it to you with my regular environment. Yeah, that's what intended to work. I mapped a Docker VM environment to my .docker host names, but usually if you use it on Windows or OS X, it should be .local. Last time I tried it, it worked.
Could you please go back to before the make create statement?
Before the make create statement,
Yeah.
there was nothing actually. Make create was just executing Composer. And before I just changed the development environment and the Docker file, and then I just ran make up. It's just that 4 commands, it's not more. What is not installed? What is greetlink? I never heard about that. But you need to execute that command. Brew install core utils. That's usually installed if you install Xcode, I guess. So it's just some basic stuff. Yeah, now I have my TYPO3 up and running. Trusted host pattern, I hate that. Refresh. Yeah, I know what I'm doing. By default, we have MySQL username and path set inside where you would expect that in etc. We have environment-specific variables like the TYPO3 context, but basically most of the settings are inside the environment YAML. And if you install something other than TYPO3 that is not installing with the composer structure in the web directory, you can just change that variable, and that will get changed, and you can run Magento Shopware or whatever you like. And here we have the settings for the MySQL root user password and database. As already mentioned, those are only environment variables that are passed to the container. So TYPO3 is able to read that. Basically, as I did not create my additional configuration file at the moment that reads the getenv, I need to do this manually. And my host name is MySQL. Let's see if you can read this. dev MySQL, and then it connects to my MySQL container. And then I can say, oh, I already have a TYPO3 database, and I can't select it because it contains tables. Continue? No. That's a pity. Ah, now I have one. Well, just trust that. Oh, there it is already. Ah, okay. It should do it because I had installed it already. Host path. Ah. TYPO3. Yeah. That works. So now I have my TYPO3 up and running. Can I skip that? No, of course I can't. I know that this already exists. Let me go to the install tool. You want to annoy me today, right? If it's the same, no, it doesn't work. What is it trying to add? Repository key. Okay. Yeah, if you show that too often, usually you will end up having that instances already set up. Then I can remove this. Continue. Do nothing. Show me the install tool. I created Inception. Well, that fixed it. Install tool password. I just want to show you the PHP version, goddammit. Where is the install tool password? Install tool password. Let me go to the install tool. Finally. As you can see, we're currently running on PHP 7.08 with TYPO3 and MySQL. And now I'm gonna back to my Docker file development, and I say, please now give me Debian 8 stable, which contains PHP 5.6, as I may remember. And then I just say make rebuild. And it throws away all my containers and it rebuilds them, which takes about 30 seconds, I guess. Configure some stuff via Ansible. Recreating, going up. And now it's ready. And now I have PHP 5.6 24. And that's an entirely new operating system with a different web server, different PHP, different config. And it's that easy to switch that version. And I could even do that with MySQL. I could add Solr. I can do whatever I want with that. And that should make your development life pretty easy. If you use the development environment, we have pre-configured Xdebug for you, so that will work out of the box. Let's see if we go somewhere in the core. Just go to the autoloader. That's used always, right? Yeah, I need the listen button. Where is the listen button? There is the listen button. I spin up debugging. And it just runs into Xdebug without any further config. And I can say, okay, this is the mapping. Yes, accept that. Did I choose the wrong one? Well, that's basically /app. Yeah, and now I have Xdebug up and running without a big hassle. Well, you could do this on Vagrant, of course, but we also prepared that. If you use that environment and you want to deploy to production, what you usually would do, what we do in the dockerfile.cloud, that's a bit of a probably confusing naming. The Dockerfile development or the production environment is intended to mount your folders, but running TYPO3 in production context. The cloud environment is built to ship all your TYPO3. So we create a packaged and built container that we can upload somewhere and just build and push it. And I think we're running out of time, right? How many time is left? 2 minutes. Damn it. Yeah, what I'm going to show in 2 minutes. Nothing more. Yeah, maybe we take the 2 minutes for questions. Have you got that running? Damn it. Yes? I hear some yeses. Yes. Yeah, well, that's usually, if doing that big workshops, it's impossible to get it running on every environment. But it should run right out of the box. And yeah. Are there any questions regarding this environment or Docker in general? Well, you may have a lot of questions, but I'm around here the entire day.
Where and how do you store the database credentials?
Where and how to store the database credentials? In what environment?
In production.
In production?
Yeah.
In production, you would deploy that to a cloud or whatever environment you have. And the environment variables in a cloud or whatever environment you're using are stored in a separate vault. So you log into your cloud provider and say, these are my global environment variables, and they are stored encryptedly, but they are seen by the container if it's running. So you don't have the credentials lying around anywhere.
Okay, how do you put them on the local configuration file?
In the local configuration file?
Yeah.
With the things I showed in here.
Okay, and that's evil.
That's evil?
Yeah, that's because environment variables are not there to store credentials. So if you do a PHP info on your system, you will publish your environment variables with these credentials, and that's you need some kind of service discovery thingy, but that gets complex.
Yeah,
that's
you do.
The question why I ask.
Yeah, actually you do. You're right. But as your MySQL container is not accessible by the outside world, but only from the app container, and your app container doesn't have anything exposed except port 80, well, what are you going to do?
Yeah.
Yeah, what are you going to do? And
what about
I heard from the
credentials?
core team yesterday they are currently working on a read-only version for TYPO3. So you can just run TYPO3 in read-only mode inside of a container, and then there's no attacking vector at all. Didn't you say that?
Yeah.
TYPO3 read-only mode will be coming? Yeah, so you heard it.
Yes.
Thanks for your great feedback. Yeah, other questions?
Service app failed to build mean?
What is?
Service app failed to build.
I don't understand what you said, sorry.
Service app failed to build unknown instruction Ubuntu 15.10.
Yeah.
Service app unknown instruction. You copied. That's not a legal name. Where is that coming from? That's not the file that is being used. You have somewhere. You commented that line out. That should stay a comment. That's just README. That's just documentation. If you want to use something, you copy that line and overwrite this base image.
So, okay. Thank you, Hans. Give it a big applause for a session. Docker of TYPO3. Thanks for giving us insight into that topic. I think you will be probably around for any questions, stuff like that.
If you didn't get it running, just come to me and we will fix it.
Okay, thank you very much. Our next session will be Polymer in Practice with Chris at 11 o'clock, which is, I think, in 8 minutes. We will switch as fast